Hello and welcome to this tutorial focusing on Backus-Naur form. In this example we're going to look at how a program will handle Backus-Naur form, or will be defined via Backus-Naur form. Previously we've looked at the rules for Backus-Naur form, and we've looked at a plain code example. Now we're going to start to look at how this might actually pan out in coding. So let's take a typical Backus-Naur type problem, and that is how a program will handle integers. Just let me get blue on that. There we go. Right, so we're going to define an integer. Just going to go back and put that into slightly different blue. There we go. Now we can say for an integer that it is made up of whole numbers, no decimals allowed. So if it was a decimal, then it would be a real number or a floating point. Let's have a little think. So it can also be any whole number, including 0, from 1 digit to any number of digits, so to infinity. Now, of course, there may be hardware and software restrictions on the amount of digits, single digits, that you could actually type into a machine and that a machine could handle. But in this case, let's work on the basis that any number from 1 to infinity, including 0. So we've defined basically what an integer is. It's a whole number, no decimal points, and it can comprise of 1 digit, i.e. 0 or 1 or 2, up to any number of digits, for example 19617852. So let's have a look at how that might work out if we define it in Backus-Naur form. So here we go. So we're going to define our integer. Our integer is comprised of a single digit or a single digit and an integer. So in other words, it could be 1, or it could be 1, 2, 3, or it could be 1, 2, 3, 4. Now, in defining an integer in this way, or any item in using Backus-Naur form, we're actually defining a recursive operation. So we've said that an integer is a single digit or a single digit and another integer. So in other words, more than one digit. We haven't yet, of course, told our program what a digit is. It needs to know, so we need to define then our digit. Our syntactical item digit is comprised of either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. So if you're using that as input, the computer, if it was defined as, I don't know, input equals int, and then you requested the input on your computer program, if you typed in A, it would immediately fall over, of course, on the definition of digit, because A does not apply in digits. And of course it would likewise fall over on the definition of integer. Let's have a look at some pseudo code on this. So, e.g. inputted an integer. First question that would be asked is there an input? If there wasn't an input, the program would either prompt again, fall over, or just close. Assuming that there is an input, then the program would ask, does that input conform to the pattern for digit? And in the lookup table, if you like, the definition for digit would be found, and the actual values that are allowed for digit would be checked. So it would check against the input, is it a 0, is it a 1, Then the program might ask, is there a further input? Because of course we're asking for an integer, and an integer is defined as either a single digit or a single digit and another integer, so you're in that recursive loop. And so the question the program asks is, does this conform to the pattern for digit? So in other words, has an integer been input, and does that input conform to digit? So let's have a look at a real example. Let's have a look at a student examination number. You might define your student ID, or your student examination number, your syntactical element, is comprised of an integer and an integer and an integer, and an integer. So in this case, in this school, for example, the student ID is comprised of 4 integers. So if that was input, the program would expect to see 4 integers, 4 single digits, 4 numbers, 4 single numbers, entered. If 3 were entered, it would either hang or crash, or just wait, hanging. If 5 were entered, then that would be a fail, because it does not conform to the definition of student ID, which is 4 integers. So, assuming 4 have been entered, then what would be looked up is, right, okay, our definition of integer is a single digit followed by a single digit. So, we loop back up and we check, oh yes, there is a single integer, or a single digit rather. In fact, there's more than that, and that conforms to that side of the rule there. And of course we need, in our program definition, our digit. And there's our definition of digit, which is 0, or 1, or 2, or 3, or 4, or 5, 6, 7, 8, or 9. So, thank you very much. That was a very brief overview of how a very common programming item, such as an integer, could be defined using Backus NOR form.